Hey guys, this is Jim. Welcome to my YouTube channel. In this video, I'll explain the basic concepts of straight lines. I focus my discussion on the four forms of the equation of the line. Concept of straight lines was first introduced by ancient mathematicians. Unless otherwise indicated, the word line is understood to be referring to the straight line. So, in the course of our discussion, the term line would be pertaining to the straight line. The straight line was used to represent straight objects with negligible width and depth. Hence, we can define a straight line as a one-dimensional figure that has no width. Straight lines have no curve in it. This is not a straight line. Of course, this is a straight line. A line can be vertical, it can be horizontal, it can be sloping downward or sloping upward. A line can be generally represented by the first degree equation ax plus by is equal to c, where a, b, and c are constants. This is called the standard form of the equation of a straight line. So that if it is drawn in a Cartesian coordinate system, say this, the y-axis, this, the x-axis, suppose this is now the line, there you go. Line now is assumed to have the equation ax plus by is equal to c. Once again, the standard form of the equation of a straight line. Any point on the line have x and y coordinates. Suppose this is point P1 with coordinates x1, y1. That point P1 on this straight line. In geometry, we know that 2 points can determine a straight line. That's why it is sufficient to just know 2 points for us to be able to sketch the line on a Cartesian plane. If possible, we can just consider points on the x-axis. Say the point A0, this point on the line in the x-axis A0, and another point on the y-axis, this on the line and on the y-axis, say the point 0B. Recall that the x-intercept is the distance from the origin at which the line intersects the x-axis, while the y-intercept is the distance from the origin at which the line intersects the y-axis. That is, this distance measuring a units is the x-intercept. It measures the distance at which this line intersects with the x-axis. On the other hand, this distance measuring b is now the y-intercept. Again, this is the distance from the origin at which the line intersects the y-axis. Notation-wise, here A is again the x-intercept and B is again the y-intercept. Now we'll examine the equations of straight lines. So let me write equations of straight lines. There you go. Again, the standard form of the equation of a straight line is given as ax plus by is equal to c, where a, b, and c are constants. This is again the standard form of the equation of the line. It can be written in other forms, such as y is equal to mx plus b. This is what we call the slope-intercept form. Slope-intercept form, the equation of the line. Secondly, y minus yi is equal to m times x minus xi. This is what we call the point slope form. The point slope form. Third, x over a plus y over b is equal to 1. This is what we call the intercept form, the equation of the line. And x cosine theta plus y sine theta is equal to p. This is what we call the normal form of the equation of the line. We'll now look at the overview of the slope-intercept form of the line. Let me write here slope-intercept form of the equation of the line. The slope-intercept form of the equation of the line is given by y is equal to mx plus b, where m is the slope of the line, b is the y-intercept, let's try to sketch a line on a Cartesian plane. Let's have this as the y-axis, there. This as the x-axis, there. And suppose we have this as the line, right? Okay, here the line is assumed to be forming an angle with the x-axis. We'll now denote the angle with by theta. The equation of the line in the form of the slope-intercept form is given as y is equal to mx plus b. That is, this is now this line here, right? Let's try to sketch a line on the Cartesian plane for us to visualize the slope. Let's have this as the y-axis. So let's have this as the y-axis. let's have this as the x-axis. Okay, so this will be our x-axis. This will be the point of origin, right? Now, suppose that this is the straight line, okay? Forming an angle with the x-axis will denote the angle by theta, okay? Now, let's have 2 points on this straight line. Let's name them as point P1 and point P2, okay? The coordinates of point P1 will be x1, y1, while point P2 will be x2, y2, right? Now, of course, this will be the value x1, okay, and this will be the value x2, right? Similarly, this will be the value y1, while this will be the value y2, okay? Now, let's try to form an imaginary right triangle. Okay, this will be our right triangle, this being the right angle. Okay, this will be our imaginary right triangle. Of course, this angle here, angle theta, will just be the same with this angle here, right? And note that this is again y1, right? This is y2. So that this opposite side of this angle theta will now be y2 minus y1. And its adjacent side, okay, referring to this imaginary triangle, will be x2 minus x1. Okay? Now, technically, the slope of a line is defined as the change in the y values with respect to the change in the x values. That is, m is equal to y2 minus y1, which is equal to x2 minus x1. By this definition, referring to this imaginary right triangle, we call y2 minus y1 all over x2 minus x1 as, of course, tangent theta. Okay? Again, y2 minus y1 being the opposite side of the angle theta, while x2 minus x1 being the adjacent side of this right triangle with reference to the angle theta. We can then write the slope as m is equal to tangent theta. Now, the point slope form of the line. So let me write here point slope form of the equation of a straight line. Okay, so here let me illustrate the point slope form of an equation of a line by drawing a straight line on a Cartesian plane. So let's have this as the y-axis here, and this the x-axis. Okay, let's have this as the force point of origin. Now suppose we'll have this line here, okay, There you go. And we'll have, say, this 2 points on this straight line. Let's have this as point xy. So this will be point xy. And another point, let's name it as point x1 y1. Okay. Now let's draw an imaginary right triangle. Right. So this the imaginary right triangle. Okay, this being the right angle. Okay. Now let's have this angle here to be denoted by theta. Okay. Clearly, this opposite side of the angle theta, referring to this right triangle, is of course y minus y1. Why is that so? Of course, this distance here is y, and this smaller distance here is y1. Okay, that's why we'll have now the difference y minus y1, right? So similarly, the distance from this point to this point, which is the adjacent side of this right triangle, but with reference to this angle, of course, this is now x minus x1. Okay. Again, with reference to this right triangle, we can recall that the slope, which is equal to tangent theta, okay, is of course equal to the opposite side y minus y1 over the adjacent side x minus x1. This will yield the equation of the line, okay, y minus y1, which is equal to m times x minus x1. This is called the point slope form of the equation of the line. Here, m is the slope, and of course, x1, y1 is a point on the line. x1 being the x1 being the x coordinate, and y1 being the y coordinate of that point, x1, y1. Again, the point slope form of the equation of the line. Now, the intercept form of the line. So let me write here the intercept form of the equation of a straight line. Okay. Now let's illustrate this by sketching a line on the Cartesian plane. So let's have this as, again, the y-axis, this the x-axis. Okay. Now, of course, this is the point of origin. Let's draw a line, okay, crossing the y-axis and the x-axis, okay, sloping downward, right? Okay, here, the line intersects the x-axis at this point, which we now label as A0, while on the y-axis, we'll have this point. We'll now label it as 0B. Alright? Once again, here, this value A, which is the distance at which this line crosses the x-axis, the distance from the point of origin, is what we call the x-intercept. And this distance here, denoted by b, which is the distance from the point of origin at which the line crosses or intersects the y-axis, we call it the y-intercept, right? Then, the intercept form of the line is now given by this equation, x over a plus y over b is equal to 1, where a is the x-intercept and b is the y-intercept. Now, the normal form of the equation of the line. So let me write here, normal form of the equation of the straight line. To illustrate this, let me draw again or sketch a line on a Cartesian plane. So let's have this as the y-axis, okay? So there you go. This as the x-axis, right? And of course, this is the point of intersection, the point of origin. Now, let's draw a line, okay, crossing the y-axis and the x-axis, right? Let's draw a line segment from this point of origin, okay, which will be perpendicular to this line, meaning the angle formed here, of course, will be 90 degrees, right? Let's denote by theta this angle here. We can now write the equation of the line in normal form given by this equation, x cosine theta plus y sine theta is equal to p. Here, p is the perpendicular distance, so that would be the p there, the perpendicular distance of the line from the point of origin to this, of course, line. And once again, the angle theta here is the angle formed by the x-axis and this line segment with length p. Thus, this normal form of the equation of the line is useful in determining the perpendicular distance of the line from the point of origin. We'll now derive an alternative equation for this normal form of the equation of the line. The equation that we'll be arriving at will be useful in converting the standard equation to its normal form. Again, the standard form of the equation of a straight line is given as ax plus by is equal to c, where a, b, and c are constants. Now, multiplying both sides by this quantity, one all over the positive and negative roots of this radical, where this is the square root of a squared plus b squared, will have ax all over this radical plus by all over the same radical is equal to c all over that radical, the positive and negative square root of the quantity a squared plus b squared. Note that this radical should adopt the algebraic sign of b in the given equation. Okay? That is, if b is positive, then this radical must also be positive. If b is negative, then this radical must also be negative. Also, the absolute value of p, no? If you can recall, p is, again, the perpendicular distance of the line from the origin. Okay? The absolute value of that length of the line segment, of course, being a length, should be positive always. Here, this p gives the perpendicular distance of the line from the origin, and this will now be this expression at the left side, meaning p is equal to c all over the positive and negative square roots of a squared plus b squared. Note that the computed value of p here is positive. It means, if the computed value of p is positive, it means that the line is above the origin. On the other hand, if the computed value of p is negative, it means that the line is below the point of origin. I hope you learned something from this video. In my next lecture videos, I'll be explaining the actual procedures in converting a given equation of the line in standard form to other forms of the equation. Don't forget to subscribe on my YouTube channel for you to receive instant notifications about newly uploaded lecture videos. Thanks for watching.